Okay, so I'm going to start talking about the uh, homework that's due on Monday. Let me start presenting that right now. For those of you that have said that you can't access the Google Doc or anything like that, I have provided a link to the PDF uh, version of the instructions, and you can just do your work on a separate sheet of paper. So, before I get into, come on, there we go. Before I get into the actual assignment, I want to point out something that's in our slides. I linked the slides in our Google Classroom. And specifically, I want to call your attention to this slide, slide 9, because I said this a couple of times in previous class meetings, and people have told me that they didn't know what I was talking about. Our rule for ionic compounds is that a positive and negative ion get together, they form a compound, and the rule is that that compound needs to have a net charge of 0. So our example over here, we have 3 plus 2 charges from beryllium. We have 2 minus 3 charges from nitrogen. That comes out to a total of 6 positive charges and 6 negative charges. Those cancel out, and that's why we're left with 3 beryllium and 2 nitrogen in our formula. So that's just a really quick reminder of that rule. In class on Wednesday, I took a look at a couple of questions from the homework. Question 2, question 3, I looked at question 1, I looked at a couple of the entries in the later questions. Today, I'm just going to look at some more sort of ionic compound formulas because that skill is probably the most important. And from what I've heard from people, it's the most difficult. So I'm going to look at question 14, and I'm actually going to give myself a little bit of room right here to work with. So for question 14, I just want you to give me the formulas of these two ionic compounds. We've got, and let's make this nice and large so that we can see. We've got barium and we've got chlorine. And the first thing you need to do is you need to check what the charge on barium and chlorine are. If we look in our model up here, we've got barium at the bottom in row number 6. It is Ba2 plus. Chlorine is all the way over on the right. It is chlorine 1 minus. So we have barium 2 plus, chlorine 1 minus. We can put that into our formula or put that into our ion notation. It's not a formula yet. 1 minus. When we crisscross these guys, the 2 from barium goes down to the bottom of chlorine. The 1 from chlorine goes to the bottom of barium. We drop the sign, so we're left with Ba1, Cl2. If we got that, we're done. If you want to be a chemist, as always, chemists are extremely lazy, so they do not like writing the number 1, so they might write BaCl2 just like that.
Go get you ready.
Lithium oxide, we have to be a little bit careful. What's up?
Oh, I was talking to my mama.
Oh, it's cool. Okay. Gotcha. All right, magnesium and oxygen. We've got magnesium, we've got oxygen. We got to check through the charges on those guys. Magnesium has a charge of 2 plus. Oxygen has a charge of 2 minus. Magnesium's in the 3rd row. Oxygen's in the 2nd row. I trust that you'd be able to find them given time, but I'm kind of blasting through this right now. Magnesium charge 2 plus. Oxygen charge 2 minus. We crisscross that, and we get magnesium. It's the 2 from oxygen. Oxygen gets the 2 from magnesium. But this is not okay because we have 2 and 2. We want to use the least number of atoms possible. And yeah, these cancel out. But if we divide by 2, then we could go from Mg2O2 to just Mg. Whoops, nope, not open. MgO. As a reminder, this is just looking at our notes. The difference between this example with beryllium and nitrogen versus this example where we have calcium and sulfur, and we have to follow this last rule, reduce the subscripts if possible. All right. This is all stuff from last week, and for those of you that were doing fine last week, that's fine. That's great. I'm happy that you're doing okay. Question 21 down here. I wanted you to take a look at elements that form more than one ion. So specifically, I'm looking at SNO. SN is tin right here. So the first thing you got to do is you got to find SN on your chart. It's in row number 5 up here. And if you look in row number 5, SN, tin, can form 2 different ions. It can form SN2 plus or SN4 plus. So when you write the name of this formula of this compound, SNO, you're going to have to be specific. Is it tin 2 or is it tin 4? And the way to figure that out is you look at oxygen. One tin atom is matched up with one oxygen atom and cancels that out. So oxygen, as a reminder, you can either look it up in the model or you can remember the last question that we talked about and remember that oxygen has a charge of -2 or 2 minus. So if one tin atom cancels out with one oxygen atom, that means that in order to cancel out the -2 from oxygen, you're going to need a +2 from tin. So tin charge is going to be, whoops, 2 plus. And that means in our name, this is tin oxide, but you have to go back and you have to make sure that the reader knows it's not just tin oxide, it's tin 2 oxide. We put the Roman numeral for 2 in that name there. And then, I don't want to do another oxide. And then looking at question 22, I'm looking at this next to last row, zinc nitride right there. So we can actually skip over to the end here and we can start this one. We can say, I'm going to put it in lowercase so we know that it's not all the way done yet. Capitalize it for me. Google Docs, how good are you? So zinc nitride, we know that's the name, but we don't know whether we need a Roman numeral or not. So we check our model, we look for zinc, and oh, I actually got this wrong. I thought zinc had multiple ions. It's in row number 4 right here. Zinc only forms one ion. It's zinc 2 plus. It's in row number 4. It's right next to copper. So this is actually our full name, zinc nitride, because it only forms one ion. It does not form multiple ions. You don't have to be specific about this being zinc 2 or zinc 3 or anything like that. I do want to. Oh, you know what? I don't think that I've asked you for. I have not been mean. I have not asked you for formulas of compounds that use ions. Yes, ma'am.
Mr. So should I write this on like a piece of paper?
Yeah. In fact, if you can't see the Google Doc, find yourself a piece of loose leaf.
I found the Google Doc, but I can't I found what you sent to through a Google Classroom, but I can't write on it. That's the thing.
You can't write on it. Okay. In that case, just like I said in there, find a piece of paper, write it down, take a picture, send it over to me.
Okay.
Cool. Okay. So with all this, I could keep babbling, but it's Friday. Not that days mean anything anymore. I'm just going to ask, does anyone have any questions about this homework or about anything in particular? And I'm hearing a resounding, not really. Cool. So I'm going to stop the recording then.